Okay, next video. So here's the problem we just did. And this was worded, say where it fails to be discontinuous. Where is it not continuous? Where are the discontinuities? We've got the exact same graph here, but this time the instructions say identify the intervals on which the function is continuous. So it's kind of the same question but different wording. Here they wanted to know where it was discontinuous. Here, where is it continuous? So it is discontinuous at the numbers that we came up with before at -3, 0, 1.5, 3, and 8. So it will be continuous on, negative infinity to -3, open parentheses, -3 to 0, 0 to 1.5, 1.5 to 3, 3 to 8, and 8 to infinity. Interval notation. The use interval notation, we want to be sure to exclude each one of those numbers, so we use parentheses. Remember, in interval notation, if you want to include a number, it's a square bracket. If you want to exclude a number, it's a parenthesis. Infinity and negative infinity always get in parentheses. And then to be mathematically, technically correct, we put between each one of those intervals the union symbol, which just means this one or this one or this one or this one. I'm not going to be picky whether you put a union symbol there or commas. I'm not going to be picky. And as far as MyLab Math, one good habit or one good thing you could do, a trick a little bit, is click on View an Example, and however they answer the problem in View an Example, that's the format that you should answer the problem. And also always read underneath the answer box. It will tell you sometimes, separate intervals by a comma. And if it says separate intervals by a comma. Now, a comment on View an Example. Do not use it a whole lot. I have had students who use View an Example for every single problem and just rely on it completely. Come quiz and test time, you're not going to have View an Example. So only use View an Example and apps as an absolute last resort. Copying things from View an Example, Symbolab, Wolfram, Photomath, whatever is your favorite, Chegg, that is not going to help you come quiz and test time. Use those only for hints. Okay, so we've seen graphically what continuity means. Discontinuous at gaps, breaks, and holes. Need some continuity facts now, because we're not always going to have graphs. So first continuity fact, polynomial functions are continuous for all real numbers. Recall, a function is polynomial if there are no variables and radicals and denominators and all exponents on variables are whole numbers. So determine where f of x equals 3x to the fourth plus 5x squared minus 4x plus 8 is continuous. And all we'd expect to see here is this. F of x is a polynomial. So continuous on negative infinity to infinity, or you could just write all reals, or you could write, if you wanted to, everywhere. If you had a real old math teacher, there's this old script R thing, which stands for all real numbers. Just get your point across. It's a polynomial, so it's continuous everywhere. Next rule, rational functions are continuous on their domains. That previous statement is equivalent to rational functions are continuous for all reals except for any number that causes the denominator to become 0. For all reals except for any number that causes the denominator to become equal to 0. Recall, a rational function has the form p of x over q of x, where p of x and q of x are polynomials. Determine where the following is continuous. So I look at it, and you can just barely see that. A little bit. I didn't mean to go in that much. This is not my favorite document camera in the world. So let's go out a normal amount. I really didn't accomplish anything, did I? There, I think you can see it. Okay, so this is a rational function. Remember, a rational function is just a fraction where the numerator and denominator are polynomials. So this is going to be continuous everywhere for all reals, except where x squared minus 4 equals 0. So I solve this little equation, x squared equals 4. Take the square root of both sides, and I left a great big gap there. You've got to remember some basic algebra things here. Little things that maybe didn't trip you up too much in algebra will cause huge problems in calculus. When I'm solving the equation and I take the square root of both sides, I must include a plus or minus. In algebra, maybe your teacher didn't punish you harshly, but in calculus, forgetting that plus or minus gets rid of half of the answers. And in the more complicated problems, forgetting that plus or minus, that tiny little mistake causes the problem to blow up. You've got to remember that plus or minus when we solve equations by taking a square root. So I get x equal plus or minus 2. And then you can write this any way you want. It's continuous for all reals except plus or minus 2. Got to have that word except. If you wanted interval notation, negative infinity to negative 2, negative 2 to 2, 2 to infinity. I don't care, test or quiz, what you give me. My math lab, my lab math, give them whatever they want. It's going to be one of those two things. But just for me, just get your point across. Now we're going to change the problem just a little bit. Determine where the following is continuous. And if you compare the two problems, they are almost the same. Just change the denominator to plus. So we'll approach it the same way. So this will be continuous for all reals except where x squared plus 4 equals 0. Take the square root of both sides, include that all-important plus or minus. And then I'm going to stop right here. This is imaginary. And we are not going to use imaginary numbers. Will not use imaginary numbers in Calculus 1. Or 2 or 3. Calculus on what's called the imaginary plane is really, really hard, and throwing in imaginary numbers makes things much less clear. Now, there are certainly places where you need calculus on the imaginary plane, but that's not what we're doing in this class. We're just never going to use imaginary numbers. So we get no real solution. And so our except part had no answer that we can use. And so we just conclude that this is continuous for all reals, or negative infinity to infinity, however you want to write that answer. But the real point to this problem was to introduce the concept that we are not going to use imaginary numbers. Number 3, odd root functions are continuous where their arguments are continuous. Okay, so what does that mean? So this is f of x equals the 7th root of 3x minus 1 quantity squared. Just reminding you algebraically there that the denominator is the index on your radical, the numerator is any power. This is an odd root. So it will be continuous where the argument, the inside. And what if I FOIL that out? That's going to be x squared minus 6x plus 1 is continuous. Well, 9x squared minus 6x plus 1 is a polynomial. Thus continuous on all reals, or negative infinity to infinity. And so since the argument was continuous for negative infinity to infinity, we can conclude that f of x equal 3x minus 1 to the 2/7 is continuous on negative infinity to infinity. And that's a good place to stop this video. I try to keep all the videos around 10 minutes.